Today we are going to start another topic of the vector calculus, that is vector addition. So we have two methods of vector addition. One is geometrical method and second is analytical method. This is also known as the mathematical method. So first we will be dealing with geometrical method. What is geometrical method and how to add vectors geometrically? Actually, there is a rule in geometrical method. So it says that if we have vector A and we have another vector B, if I have to find the resultant or I have to just find the net of these two vectors, so the rule is that we have to take the tail of this vector B and put it on the vector A such that B vector shall not change. So we have to displace this vector B parallelly, because shifting a vector parallelly does not change a vector, so we have to take this vector B and we have to put this vector B, we have to put the tail of this vector B on the head of A. So suppose the vector A and we have another vector B, so I will take the tail of vector B and I will put this on the head of vector A. So according to the geometrical method, in order to find the resultant of this vector A and vector B, I will just join the tail of this vector A with the head of vector B. So this third side or this third vector which I draw from vector A, tail of the vector A to the head of the vector B, it will give me the resultant of these two vectors. So this is a this is a rule in the geometrical method. If I will take two vectors, so we have to take first vector, then we have to take second vector, and such that such that the tail of the second vector, we have to put the tail of the second vector on the head of the first vector. Then the third vector will give me the resultant of these two vectors. But I have to draw such third vector in such a way that the tail of the third vector shall be on the tail of the first vector and its head shall coincide with the head of the second vector. So this is the rule we have to remember in geometrical method. So important thing we have to remember is that when we shift a vector parallel to itself, the vector does not change. So it does not change the direction of the vector, as we are not changing the direction of the vector nor magnitude, so it will remain same when we shift a vector parallel to itself. Now, so first thing is that I will take two vectors when two vectors are in same direction. So I have to find the resultant of these two vectors. These two vectors are in the same direction. I will take vector A, suppose this is vector A, and this another vector B. So I have to find the resultant of these two vectors. So I remember the rule. I will take vector A, that is this vector A, and I will put the tail of B on the head of A. So this is our vector B. So third vector, joining the tail of A to the head of B, it will give the result. So I will draw it separate here. So this will be the resultant of these two vectors as per geometrical method. So I can write resultant vector R, it will be equal to A plus B vector. So here the resultant vector has the same direction as that of A and as that of B. So this will be the resultant vector. Now suppose we have two vectors that are in opposite direction. I will take again vector A and this is our vector B. So I have to find the resultant of these two vectors. So I will take, as per rule, I will take vector A and I will put the tail of vector B on vector A. So the another vector B will be like this. This will be the B vector. So as per rule, so these two are opposite to each other. So the resultant of these two vectors will be this will be the resultant of these two vectors. So this resultant R, it will be vector A minus vector B. Actually, these two vectors are anti-parallel to each other, so their resultant will be simple subtraction of these two vectors, and geometrically this will be the resultant R vector, and its direction will be the same as that of A. Here A is larger in magnitude than B, so hence the resultant vector will be always will be having the direction same as that of A vector.